There are lots of ways for a videographer to stabilize their footage. If your camera doesn't need to move, a tripod is ideal. Where camera movement is required, devices such as a gimbal or a Steadicam will ensure your movement is free from bumps and jolts. But what if you can't afford that equipment, or you need to be able to run and gun to capture your subject? The shaky camera work that can arise from hand holding your camera can be distracting from your audience. In these circumstances, the image stabilization options available on your camera can save the day. In the world of still photography, image stabilization ensures sharp images at slower shutter speeds. For videographers, this isn't an issue, as shutter speeds of 1/48th and 1/60th of a second are the norm. The resulting motion blur on individual frames can actually improve the appearance of motion in your footage. That said, image stabilization systems are still ideal for mitigating the shakiness of handheld footage. Image stabilization comes in three forms: optical, sensor shift, and digital. Optical stabilization is built into some lenses and works by incorporating a floating lens element, which moves to compensate for the camera shakiness. Gyro sensors detect and relay motion to a microcomputer, which controls motors that shift the floating element so as to counteract movement of the camera. The main advantage of optical stabilization is that since it's built into the lens, it'll work on any compatible camera. Optical stabilization will also compensate for greater movements than sensor shift stabilization will, and so it's more effective with longer telephoto lenses. Stabilized lenses, however, are more expensive and heavier than non-stabilized lenses. There are also limitations on the range of movements for which lens-based stabilization systems can compensate. Typically, in-lens stabilization systems only compensate for movement along two axes: pitch and yaw, which is a fancy way of saying vertical and side to side. Furthermore, as optical stabilization involves moving elements within the lens, it can adversely affect the quality of bokeh in an image. In-body or sensor shift stabilization work on the same principle as lens-based optical stabilization, though in this case, the tech is built into the camera body. Again, gyros are used to relay information about the camera's movement to a microcomputer, which controls motors to move the camera's image sensor to compensate for wobble or shake. The main advantage with in-body stabilization is that all lenses used with that camera will benefit from the stabilization, even older mechanical lenses. Sensor shift-based systems can compensate for types of motion that can't be countered by the lens-based stabilization. Some cameras offer up to 5 axes of stabilization: roll or rotation around the lens axis, horizontal and vertical stabilization. This is in addition to the pitch and yaw countered by optical stabilization. Some newer cameras include dual image stabilization that incorporates sensor shift stabilization that works in conjunction with lens-based systems to maximize the stabilizing effect. Digital stabilization, also known as electronic image stabilization, is an in-camera version of the image stabilization that's included with some nonlinear editing software. Rather than using the full area of the camera sensor to record an image, a digital stabilization system only uses around 90% in the center of the chip. When the camera detects movement, the portion of the sensor used to record the image shifts in the opposite direction to compensate for the motion. Movement can be detected with motion detectors, as well as optical and sensor shift stabilization systems, or through an analysis of the image itself. As digital stabilization involves cropping the sensor in order to capture an image, it can lead to a loss of resolution. Systems that work by analyzing the image can be fooled by moving subjects in the frame or by camera movements such as panning or tilting, resulting in a juddering of the image. While image stabilization systems can be useful to smooth out handheld footage, they can cause issues when using a tripod, so in those cases they should be switched off. When using stabilized lenses with some cameras to shoot video, the stabilized system may not be activated until you actually press record, possibly causing a momentary jitter in the image. If this is an issue, remember to allow a second or two at the start of each shot for the stabilization system to settle. In addition to general stabilization, some systems include different operating modes, such as switching off the stabilization on one axis to avoid the issues that can arise when panning or tilting a camera. Image stabilization systems are very useful in reducing camera shake when shooting handheld, and with practice, you can learn to achieve smooth tracking shots. While they'll never be able to replicate the floating glide that can be achieved with a Steadicam or gimbal, image stabilization systems are another great tool to help you improve your video footage.
Continued learning and practice, as well as taking refreshers on the basics, will help keep your skills sharp. Check out our video courses to stay on top of your game. Find a course by visiting videomaker.com/courses or click the link in the description.